Hey everyone, it's Justin again. In this video, we're going to learn what an equation is and how to determine if a number is a solution to an equation. Then we'll do one example problem. So far in this course, you've been learning about expressions. So what is an equation? An equation is two equal expressions joined by an equal sign, which looks like this. The most important thing to remember about an equation is that the two sides have to be equal. You can imagine putting them on a balance scale like this. When both sides are equal, like say if we put 7 on both sides, then the scale is balanced and we can say that this equation is true. As long as the two sides have equal value, they don't even have to look the same. So I could rewrite 7 as 2 plus 5, or 8 minus 1, or 2 plus 2 plus 2 plus 1, or anything else you can think of that makes 7. I could even rewrite both sides like this. All of these would still be true because each side still has a value of 7. Now, if the two sides are not equal, like say 7 and 9, then the scale would be unbalanced. And we would say that this equation is not true. We can also show this by putting a line through the equal sign. When an equation only involves constants, we can just use the order of operations and simplify to check if both sides are equal and the equation is true. But what if we introduce a variable here? For example, if we put x on one side of the equation and 5 on the other side, well, a variable like x can represent any number. So how am I supposed to know this equation is true? This brings us to another new vocabulary term, solution. A solution to an equation is a value for the variable that makes the equation true. So for this equation, is 10 a solution? Well, if I substitute 10 for x, I get 10 equals 5. Is that a true equation? No, this is definitely not true, so 10 is not a solution. What number do you think is a solution to this equation? What about 5? If we substitute 5 for x, we get 5 equals 5, which is true, so 5 is a solution. As you might guess, most of the time our equations will be a little more complex than this, so let's kick things up a notch. Is 5 a solution for this equation? It's not so easy to tell just by looking now. Well, think back to our definition. A solution is a value for a variable that makes an equation true. So if 5 is a solution, then I should be able to substitute it in for k, and I should wind up with something that is equal on both sides. The only way to check is to just substitute and see what we wind up with. Let's start on the left side. I'm going to substitute 5 for k. So I wind up with negative 4 times 5 plus 8. I need to make sure that I use my order of operations to simplify. So I'll start with negative 4 times 5, which makes negative 20. And I'll add 8 to that to get a final value of negative 12 on the left side of this equation. Now let's check the right side to see if it's equal or not. Pause the video here and substitute the value of 5 for k on the right side of the equation. When we substitute 5 for k on the right, we get negative 6 minus 5, which makes negative 11. So if k is 5, our equation would look like negative 12 equals negative 11. What do you think? Is 5 a solution to this equation? No, 5 is not a solution to this equation, because if we substitute 5 for k, our equation would not be true. Let's do an example problem together. Our example problem asks which of these is a solution to 5 minus 2j equals 11. and we have 4 possible answers to choose from. How do you think we could figure out the answer to this problem? Well, to see which of these numbers are solutions, we'll have to substitute each of them into the equation and see if they make the equation true. Pause the video here and give this a try on your own. I'm gonna work my way down, so I'll start by trying j equals 3 first. If I substitute 3 for j, I get 5 minus 2 times 3 equals 11. Using my order of operations, I'll do the multiplication first. 2 times 3 makes 6, and then I'll do the subtraction last. 5 minus 6 makes negative 1. So if j is 3, my equation would look like negative 1 equals 11. Well, that is simply not true. So 3 is not a solution to my equation, and I can try the next one. If you were stuck before, pause the video here and give this another try on your own now that we've done one together. Next, I'll try to substitute 6 for j, which gives me 5 minus 2 times 6 equals 11. Using the order of operations, I'll multiply first, and then subtract, to get negative 7 equals 11. That's also not true, so 6 can't be the solution either. What about negative 3? If I substitute, I get 5 minus 2 times negative 3 equals 11. I'll multiply 2 times negative 3 first, which makes negative 6. So I wind up with 5 minus negative 6. Thinking about subtracting a negative is always kind of tricky, but I know that minus negative 6 is just the same as adding positive 6. That's a lot easier to think about. 5 plus 6 makes 11, so I have 11 equals 11. And that's true. So is j equals negative 3 a solution to this equation? Yes, it is, because it's a value of our variable that makes the equation true. Most equations that we will look at in algebra only have one solution, but it is possible for an equation to have multiple solutions. So it's always a good idea to check that last answer choice just to be safe. If I substitute negative 6 for j and simplify, I get 17 equals 11, which is not true, so we can rule out our answer choice D and be 100% confident that C is the only solution to this equation. The most important thing about equations is that both sides are equal. So to check if a number is a solution to an equation, substitute it in for the variable and then see if both sides are equal. We are just about finished with this lesson video, so take another look through your guided notes and make sure that you have everything filled out. Then you can move on to the practice game. Do your best, and I'll see you next time.